Welcome back, raspberries and blueberries. I hope you guys had a wonderful break. I'm sorry I can't be with you today, but unfortunately we are wrapping up some of the state assessment grading. The good news is I will be back tomorrow, so I'm very excited to see you guys. With that said, we're going to get started with our new unit, which is going to focus on geometry. Okay, so today we're going to kind of hit the ground running. We're going to look at some different shapes and some different attributes of those shapes, and then we'll go from there. All right, so the first thing before we get started, I want you to make sure you have your notes paper out, okay? As we go through the video, you're going to copy down information, so this way you have it as a hard copy. Okay, so what I would like you to do now is to pause the video and take 30 seconds to think about what comes to mind when you hear the word prism. Okay, so pause the video, take 30 seconds, think quietly to yourself, and then we'll go from there. All right, so prisms. A prism is a solid object with two identical ends and flat sides. There are two things that define what a prism is and classify an object or a shape as a prism. And those are as follows. So first, the sides of a prism have to be parallelograms. And just to kind of refresh your memory, a parallelogram is a four-sided shape with opposite sides that are parallel. Okay. The second thing may not make a whole lot of sense right now, but it's something that we're going to get to, so I just wanted you to make sure that you had it down in your notes, okay? And that is that for an object to be a prism, the cross-section has to be the same all along its length. So now cross-section is something that you should have talked about a little bit last year, but it is something that we'll definitely get into a little bit more, so if you're not sure what that means, not to worry, we will get to it eventually. Just kind of put it down so that this way it's there and we can come back to it, okay? So here are a few different images of different prisms, okay? The top two are ones that come up quite frequently, so you need to know what those are. So we have a triangular prism, we have a rectangular prism, we have a pentagonal prism, and we have a cube. The reason why I wanted to show you these shapes was to kind of show you where the names come from. So if we take the triangular prism, okay, if you look at the base, what shape do you see? A triangle. Okay, and so that's where the name comes from. A pentagonal prism, if you look at the end, you have a pentagon. So that's where the name comes from. Okay, a cube, I included this because a cube is a special type of rectangular prism. It's special because all of its sides are exactly the same. They're congruent, they're equal, however you want to phrase it, but it's still a rectangular prism, okay? Sometimes you'll hear it referred to as a regular rectangular prism. When we use the word regular with geometry, it just means that it's congruent or equal, okay? I do have a question for you. So, is a pyramid a prism? What I want you to do is I want you to pause the video, take 30 seconds, and think about this question. You can use your notes that you just took, and you can think about the images that I just showed you. Okay, so is a pyramid a prism? Pause the video, take 30 seconds, see what you can come up with. All right, so is a pyramid a prism? What you should have decided upon is no. And the reason being because it does not have two identical ends. So if you look at the pyramid here, all right, the base here is a hexagon. It has 1, 2, 3, 4, 5, 6 different sides. But if you look on the other side, it does not have a hexagon as a base or an end. So it only has one hexagonal base, okay? So therefore, this would not be a prism. All right, so now what we're going to do is we're going to look at a specific characteristic of prisms, and we're going to look at volume, okay? What I want to do is I want to show you a video quick, just so we can visually see what volume really is, all right? Here you go. Okay, so I'm not going to make you sit through the whole thing because if we did, we'd be here for hours. But the whole point of showing you that is volume represents the amount of space inside an object. So with the video I just showed you, the water filling up the container would be the volume, okay? That's showing you the amount of space inside the water jug, okay? The great thing about math is that we can use numbers to put a quantity with volume. In other words, we can come up with an object's actual amount of space inside. And the way we do that is using formulas. So here's the general formula for the volume of any prism. Okay, so V represents the volume, B represents the area of the base, and H is the height. Okay, so I could give you any prism, and you should be able to take this and tell me what the volume would be. Okay, as I said before, there are some prisms that come up more frequently than others, and those we can create specific formulas for. So the next one on your sheet, you have a rectangular prism. So this, everyone should know the formula for. Okay, so the volume is equal to length times width times height. So the length represents the entire length of the prism, and then the width and the height come from the base, okay? So really, this is the area of the base times the length. So it's the same as the formula we saw before, just now it's specific towards this type of prism, okay? The next prism you have is a triangular prism, okay? And this one's a little bit more complicated, but still the same idea. So volume is equal to the area of the base times the height of the prism, or the length of the prism. Okay, in this situation, we have a triangle as a base. So to find the area of a triangle, you need to do 1/2 times the base times the height. So that's where this half BH comes from. It's the area of this triangle here. Okay, and then to find the volume, we need to take that and multiply it by the length of the entire prism. So that's where the big L comes from. Okay, finally, we have a cylinder. So the volume of a cylinder we find by using the formula V equals pi r squared h. And so again, it follows the same pattern. So it's the area of the base times the height of the whole prism. So the base in this case is a circle, and we know from what we talked about with circles before, area is equal to pi r squared. Okay, so we'd have to take that, whatever the area is, and multiply it by the height of the prism. So that's it for volume, okay? What I want you to do now is to try the following examples on the back of your page using the information that you just came up with, okay? If you finish early and want to try some of the other problems, by all means, I would be very, very supportive of that. But please make sure you're working through these independently, and please make sure that you're doing your personal best. All right, good luck.